Okay, let's dive into this. What actually happens when an AI starts winning Nobel Prizes? I mean, seriously, think about that for a second. We are living in this incredible moment where the very nature of scientific discovery is being fundamentally rewritten. Think about the speed of modern breakthroughs. We're so used to science moving at this really steady, methodical pace, right? Decades of grinding research leading up to a single eureka moment. But what happens when our most powerful tools suddenly learn to think alongside us? What happens when artificial intelligence goes from just a calculator to an actual, literal co-pilot in the lab? Well, the answers to those questions are exactly what we're going to be looking at today.
Welcome to The Explainer. Today we're taking a pretty wild journey through the frontiers of scientific discovery, specifically looking at where we're heading in 2026. We are going to explore this from the micro to the macro. We'll start way down at the absolute smallest, invisible building blocks of matter, and we will literally scale all the way up to the cosmos. It's a massive journey, but the underlying thread connecting all of it is how technology is fundamentally changing what it means to be a scientist.
Here is our roadmap for today. We'll be looking at AI as the ultimate lab partner, mastering the quantum realm, rewriting biology and health, upgrading our planet, and finally discovering new worlds. Let's get right into it. Section 1. AI, the ultimate lab partner. You know, artificial intelligence is no longer just this basic software tool we use to crunch numbers at the very end of an experiment. Not anymore. It's really become the narrative glue holding modern science together. It's totally supercharging the scientific method across 3 distinct phases: generating hypotheses, designing experiments, and then analyzing the data. Instead of human scientists spending years just trying to formulate the right question, the AI is jumping in to help generate the hypothesis. Then, it's helping design the actual experiment to test it, and finally analyzing all that resulting data. We're moving from a human speed bottleneck to an AI-assisted sprint across medicine, chemistry, biology, and physics.
Section 2. Mastering the quantum realm.
So, we're transitioning down to the microscale now, and this is where our new AI copilot is doing some of its most mind-bending work. Historically, material science relied heavily on decades of trial and error, basically mixing things, testing them, failing, and trying again. But now, by combining AI with quantum physics, researchers are driving the rapid discovery of brand new materials. And this brilliantly illustrates the shift because scientists just use this exact combo to identify highly complex, copper oxide-based, superconducting materials way faster than traditional methods ever would have allowed.
So why does finding these materials even matter? Well, it absolutely accelerates the hunt for a room temperature superconductor, and if we actually nail that, it completely transforms our daily lives. We are talking about zero-loss power grids that deliver perfectly efficient electricity, vastly more powerful computers, cheaper and much more accessible MRI scanners for your local hospital, and frictionless high-speed transit. It literally rewrites the rules for electronics and energy.
And while we're zoomed in on the quantum level, researchers have also proposed these incredibly efficient fault-tolerant quantum architectures. In plain English, that essentially reduces the sheer massive amount of hardware we used to need to run incredibly complex quantum calculations. This is a huge, highly practical step toward building large-scale quantum computers that actually work in the real world, outside of a strictly controlled laboratory. Section 3. Rewriting biology and health. All right, let's scale up from the invisible quantum world to the human biological level. We're talking about synthetic cells, basically simple artificial living systems. And scientists are making staggering progress toward creating these from scratch. Creating artificial life in a dish means we could eventually engineer these systems to manufacture entirely new medicines, or maybe produce biodegradable materials to replace plastics, or even completely clean up heavy industrial processes. We are quite literally learning to program biology the exact same way we program computers. It's wild. And let's look at how this builds into the broader future of medicine. Because it's not just synthetic biology. Scientists are zeroing in on technologies that are nearing widespread impact as we speak. Think about mRNA therapies. We're expanding those way beyond just vaccines to target highly specific cancer proteins. Then, you combine that with AI-driven healthcare, where predictive algorithms can flag early-stage sepsis hours before a human doctor ever could, completely personalize your treatments, and monitor your recovery. We're looking at a medical revolution that is rapidly changing human health and wellness as we know it. Section 4. Upgrading our planet. Now we zoom out to the macro scale. This is where cutting-edge science goes head-to-head with the biggest global infrastructure challenges of our time. We're tracking next-generation battery materials that make energy storage cheaper and hold a charge much, much longer. We're seeing renewable energy innovations that capture solar and wind power with vastly better efficiency, and advanced recycling technologies that can now break down waste at the molecular level so we can actually reuse it. This isn't theoretical. This is the physical upgrade of our planet's energy and waste systems happening in real time.
Section 5. Discovering New Worlds. Which takes us to our final destination, expanding all the way out to the ultimate cosmic scale. Now, what's really interesting about this slide is, well, over 100 new exoplanets have been recently discovered. How did we do it? By using machine learning techniques. Astronomers are taking massive, overwhelming amounts of telescope data, feeding them into AI systems, and the AI is catching exoplanets that human eyes completely missed.
And it's not just about adding numbers to a ledger. These AI-assisted discoveries are fundamentally expanding our horizons. Astronomers have confirmed new, potentially habitable planets that are relatively close to our own solar system. We are drastically improving our understanding of exactly how planetary systems form, and by doing that, we are aggressively accelerating the search for extraterrestrial life. We are peering out into the dark, and AI is essentially acting as our ultra-bright flashlight.
So we end exactly where we began. With AI as our co-pilot, is there any limit to human discovery? From discovering new superconductors with quantum physics, to engineering synthetic cells, to completely overhauling our planet's energy grid, to finding habitable worlds light years away, all these breakthroughs point to one core truth. AI, biotechnology, quantum computing, and advanced materials are the engines driving the most significant scientific advances of our era. The very tools we use to understand the universe have evolved, and that means the universe of what we can discover has just been blown wide open. It really leaves you wondering, what exactly are we going to find tomorrow?